upcoming DevOps related sessions, because this month is completely dedicated for DevOps. So our next session is on 16th December. So that is embracing DevOps effectively to increase productivity by Chamenda. He's a Microsoft MVP from Sri Lanka. And we also have some really interesting boot camps and sessions. Sorry. So it's APAC Data Sessions 2020 Bootcamp, which is happening this week, Saturday. So it's a whole day event from 9 to 5 p.m. So if you are really interested in data related activities, so you can join this session. And they are from 8 countries, speakers, different countries, Asia countries. They are presenting, and it's really going to be a nice event. And we also have our YouTube channel. So all our session recordings will be available on the YouTube channel. You can just go and subscribe by the QR code, or you can just go and click on the subscribe button on the MVP United Professional channel. And you can see all our previous recordings, very really interesting, nice sessions available there. And you can also go for there are some Chartbusters sessions available. You can just go and. So before start, there is some reminders. So please keep yourself on mute. And if you have any questions, raise a hand. And then we can unmute yourself and you can ask the questions. And this session is being recorded. And if you like the sessions, please help to spread the words on your social media channel. And yeah. So thanks for joining. So yeah, now Damian, you can share your screen. And
great, thank you. I'm just going to do this, share that screen. I'm going to try and get Teams to give me some nice stuff as well.
Yeah, sure, no problem.
Is that sharing now?
Yeah, I can see your screen.
Okay, awesome. So I'm, for everybody watching as well, I'm going to share that screen, but I'm also going to adjust the camera too. So you have the choice. You can look at the screen, or you can look at me in the picture as well. Up to you. So look, thank you, Asif, and thanks everybody for joining me. It's really good to speak to people remotely. As was already mentioned, I'm a cloud advocate at Microsoft, and I used to spend a lot of time going to conferences around the world and speaking about DevOps, and lately MLOps more than DevOps as well. I've been doing this for almost 10 years now in one form or another, and I've always kind of been a developer background and then moved through the process of getting good software out there, and the process of getting good software out and pushing stuff into production in a nice, safe way. So this is kind of what inspired me to write this talk, which is about the pragmatic side of DevOps. So there's two sides to it. There's one side of the industry that does DevOps because they're told to, right? They follow the bouncing ball, they follow the steps, they have CI/CD, but they don't really know why they're doing it or care about why they're doing it. And then there's the other side that is trying to do everything absolutely properly and the exact right way to get what they're supposed to be doing in place so they can push their code into production in exactly the right way. The pragmatic side is kind of sits somewhere in the middle. It's using the proper techniques and patterns that people use to deliver software to production in a really nice, clean way, but it's doing so in a way that actually solves the problems that team has, rather than just using all of the best practices and trying to implement everything from start to finish. So when I talk about pragmatic, what I'm really talking about is I'm talking about what we do that's sensible and realistic, but doing it in a way that's based on practical rather than just theoretical ideas of how to do DevOps. So I have a strong belief that it's more important to know, or it's very important to know the theory behind why we do all these techniques. And without knowing that theory, you're just kind of following the steps that somebody gives you without knowing why you're doing it. So if you want to be pragmatic, you need to know why you're supposed to be doing these things and what problems they're supposed to solve. So pragmatism is really, really important if you actually want to get your software delivered properly. But I really believe that you can't be pragmatic without knowing exactly what you're trying to achieve when you're being pragmatic. So let's talk about, I'm just going to do this, sorry. Let's talk about, not just what you're trying to achieve, but how you're trying to achieve it. So let's talk about essentially what I'm going to talk about today. So today I am going to talk about, I'm going to give you recommendations. I'm going to give you ideas and practices that you should be able to take home yourself. And I'm going to give you some strategies for taking home as well. So I'm going to give you all of these things. I'm going to also tie them back to the guiding principles that I follow when it comes to DevOps. So all of the leaders in this field speak about DevOps in particular ways and what's important. And I'm going to tie all of these recommendations back to those guiding principles rather than just saying this is what you should do. What I won't do, though, is tell you to use a specific technology or a product. So I work for Microsoft. I use a lot of Azure DevOps and I use a lot of GitHub. But I've also obviously used Octopus Deploy. I've used Jenkins before. I've used Travis. I've used TeamCity. I've used a whole lot of other products. And they also solve the problems. Now, in some of the organizations I worked for, these technologies were solving the problems really well. So why change what works? So I'm not going to tell you you should drop whatever you're doing and start using Microsoft stuff. It'd be wonderful for my job if you did, but that's not the important part of this. The important part of DevOps is doing this stuff properly. And I'm also not going to give you any silver bullets. I'm not going to give you any, this is the way you solve this problem in all cases. So if you're looking for that, unfortunately, this is not the session. And I would argue that silver bullets don't really exist in this industry. You really need to understand what your problems are specific to your organization and solve those problems. So the principles that I'm going to be basing this on, these guiding principles that I talked about, there's really three of them that I look at. There's Microsoft's definition of DevOps, which is really important, and I'll get to all of these in a second. And then there's a couple of ideas from Gene Kim. So Gene Kim is an author and a DevOps advocate and a researcher and all of these things, and he's written a number of books. And some of the concepts in these books are really, really useful for working out how DevOps should work. And I love these two that he has. He has the 3 ways of DevOps and the 5 ideals of DevOps. And we'll talk about what they are soon, but I think those are a really good basis, these 3 things together, to talk about what DevOps is and what it should do for you. So let's start with Microsoft's DevOps definition. So this was written by my now skip level boss, Donovan Brown, who you may have heard of. I saw him on one of the slides previously. And so Microsoft's definition of what DevOps is that DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Now, I've highlighted what the most important part of this is, and that's the word value, right? It's really important to understand that DevOps is not about delivering code into production. It's not about delivering features or bug fixes or anything like that. It's about delivering value. Now, there's a big difference between delivering code and delivering value. It's very easy to work for a long period of time writing some code that ultimately doesn't get used, right? Or it does get used, and even worse, people don't like it. Right. If we're not providing value to the end users, then we've been wasting our time. And so this is a really fundamental part of what DevOps is and what it should do for you. So that's worth remembering as well. Everything can be tied back to that value. Gene Kim's 3 ways I really love. So he talks about the 3 ways of DevOps, and there's a few different ways you can think about how DevOps works and how the flow of DevOps should work. So the first way is about systems thinking. So the easiest way to describe this is you can think of development on the business side. That is the dev side is what implements what the business needs, right? The customer side is the operating of that software, the ops side, keeping it available, keeping it working, and deploying those changes to that customer, right? So all of these obviously are a team effort, but we're really taking the ideas of the business to the customer. Now, what's important with this first way of thinking is that you're thinking about that whole process from dev all the way through to ops and from the business idea all the way through to the customer. It's important you think of that whole system together, not just the development part or the QA part or the testing part in isolation, and that you optimize the whole system from one end to the other. So improving your development lifecycle doesn't really make much sense if you are still deploying every 6 months. You're making some things more optimal, some things faster, and some things better, but ultimately you're not delivering value any faster than you were before. And there are downsides to doing that kind of thing too. So that's the first way, systems thinking from one side, business side to the customer side, right? The second way is about amplifying these feedback loops. So this is where we come back the other way and we look at what the customer is doing in production and we feed that information back into the business so we can work on better software, we can make improvements. Now, the second way is about amplifying this feedback. So again, if we talk about deploying every 6 months, we don't have a very good feedback loop. In a 6-month period, we've probably implemented a ton of different features and a ton of different bug fixes. If something goes wrong when that gets to production, tying that feedback back to the work that it was happening is really hard. Now, if you're a developer like me, you'd understand that if somebody asks you, hey, you know this feature you wrote 6 months ago, can you tell me this intricate detail of it? Or there's a bug in this. I don't recognize the code that I wrote 6 weeks ago, right? Or 6 months ago. There's also the fact that you've probably deployed so many changes. It could have been anything that caused this bug that you're only seeing in production as well. So the feedback loop is how easily can you tie the thing that's happened in production to the work that was done. And the easiest way to do that is to shorten those feedback loops, deploy small pieces very regularly so that you know what has changed each time. And that's how you can amplify those feedback loops. So that's the second way. The third way is developing this culture of continual experimentation and learning. So this is the idea of being able to iterate really, really quickly internally inside this whole cycle from the business to the customer and learn from those mistakes. So it's one thing to make sure you have a really good pipeline from idea all the way through to production. But if you don't ever iterate on that process, you don't ever try and improve that process and learn from those failures, you're kind of stuck at that local optimum, right? This local best case of, well, we can get from here to here in 6 hours and we catch some of the bugs, right? We need this culture of being able to continually experiment, continually add new features to that pipeline and learn from the failures that we have as we go. So these three things together are Gene Kim's 3 ways of thinking about DevOps. They're these principles that kind of underpin what DevOps looks like. Now, these were presented in a book that you may have heard of that he wrote called The Phoenix Project. Fantastic book. I co-authored a textbook, like a Team Foundation Server 2013 textbook, so it was that long ago. And it is a really dry read. I mean, I wrote the thing and I haven't read it. It's so boring. But it's obviously like a guide to using the product. The Phoenix Project, though, is a novel. Like, it's an actual story about some stuff that happens in an organization. It's a really good read. And while you're reading it, you'll learn a lot of these ideas. So these the 3 ways gets introduced in the Phoenix Project. I would highly recommend reading that if you haven't already. All right, so the 5 ideals is that final part of these fundamentals that I want to base everything on. And again, this comes from Gene Kim, and it actually came from another book I'll talk about at the end. So the 5 ideals are locality and simplicity, focus, flow, and joy, improvement of daily work, psychological safety, and customer focus. Now, locality, let's start from the beginning, right? Locality and simplicity means how easy is it for you to do your job and actually deliver value in a local sense? Do you have to go out to 5 or 6 different teams to actually get something done? Or are you capable and empowered to make changes on your own and see those changes all the way through to a production system? Is the work that you're doing simple, or does it require a lot of extra configuration, a lot of extra tools and processes to get something done? In other words, how easy is it to make changes that actually provide value? Focus, flow, and joy kind of comes from this as well, where if you are able to sit down and work and focus on the actual problem that you are trying to solve, whether that's code or improving the infrastructure or something like that, you'll get into this flow state and you'll be able to actually deliver value a lot better. You can focus on a single task rather than having to speak to somebody else or stop and start to work out what the next process is in our software development. And this leads to this kind of joy of writing code. I know many of you, if you're developers, have sat there and worked on a particular technical problem and the time's just flown by and you look up and it's 6 hours later. I know I've done that as well. So that is when you have this focus, flow, and joy. And that's an ideal scenario for delivering value. Improvement of daily work is an interesting one as well. Our CEO, Satya Nadella, has actually been quoted as saying this as well, that if there is a choice between, writing some new code and implementing a new feature or improving the way our tools work so that we can deliver features better in the future, we should choose that improvement every time. So this is an important part of an effective DevOps practice, is that we improve the way that we work on a daily basis. If there are things that are painful and annoying that you have to do all the time, like, for example, you have to follow these 5 steps, otherwise your tests won't work in your CI pipeline. That kind of stuff can be super detrimental for actually getting value out the door. So putting aside time to improve the daily work that you do is really important. Psychological safety, you can talk about this in a few different aspects, but ultimately it means, do I, as an employee or as a person working on a team, feel safe to suggest new changes or to point out things that I don't think are going to work or point out problems with our application? Or am I going to be made the scapegoat or be told, don't rock the boat, just let things happen, that kind of thing? If everybody in that team feels safe enough to suggest things or point out problems, then you're going to end up with a much better outcome for your team and for your software delivery. And I'm not just saying this as this would be a nice thing to have in all these teams. There's actual research behind this stuff. Some of you may have heard of an organization called DORA, DevOps Research and Assessment, and a researcher, Dr. Nicole Forsgren. They produced the State of DevOps report, or used to produce the State of DevOps report. And in that, there is real research that shows that organizations that have a high level of psychological safety actually deliver their software to customers more efficiently and more effectively as well. So it's not just this would be a nice thing to have. There's research behind this saying it improves software delivery outcomes, which is really interesting. And 5 really talks about that value, the customer focus. Nobody that you're selling your product to really cares how good your payroll system is, but they do care how available your software is or how many bugs are in it, right? So that should be your focus rather than all of the peripheral stuff that happens in your organization. So focusing on that customer and their value is another ideal from Gene Kim. So these came from another book, which is kind of a sequel to the Phoenix Project. It's called the Unicorn Project. And it's a similar story. It kind of happens in the same organization, almost as a parallel to what's happening in the Phoenix Project. But this one's focused a little bit more on developers, whereas the Phoenix Project was a little bit more on the ops side of the DevOps. This is more on the dev side of the DevOps. And there's some stuff in there, great stuff about data and machine learning and things like that as well. Again, it's a novel, highly readable. I would really recommend reading it. It's a fantastic book. All right, I'm going to take a quick break. I can see that there's a couple of questions. So one question there. What would you advise to people who work in an environment where it is not safe to propose changes? And that is a super hard question. So I'm assuming you're talking about the psychological safety aspect of it. I'm in an extremely privileged position where I can say, if that was me, I would try to look for somewhere else to work. But I understand that that is not an option for a lot of people. It's not that easy to just pick up and take another job, right? I would love to say that that is the solution. And if you can do that, I would say that is. If you feel that it is that your ideas aren't being listened to, often it's a good idea to kind of pick your battles. So if something you think, if you're implementing a feature that is, you think actually harmful, that's probably the time to speak up. But if it's just not ideal from your point of view, sometimes, biding your time and waiting for the right arguments is the pragmatic thing to do, I guess. It's not a great answer because there's not really a great answer. A lot of the biggest problems in DevOps come from culture, from organizational culture. Certainly not the technologies, not the tooling. It's the culture of the organization and whether you can actually suggest these changes. If they're technical changes, things like your organization doesn't want you to spend time writing unit tests, that's where some of the kind of under the radar techniques could be used. And yes, you've pointed out as well, there's three options. You can accept it, you can change it, or you can remove yourself from it. And I would completely agree. Those are kind of your three options. And it really depends on how safe you are and how safe you feel performing any of those options. In terms of the changing it stuff, if you can't get official buy-in, sometimes showing the results of this, of your changes, are really handy. And I recommend this sometimes for organizations that are reluctant to do CI/CD, so continuous integration, continuous deployment. It's really easy to just set up a pipeline for a code base that you already have and deploy it to a test environment, even if all of this is just on your local machine, but do that in an automated way and then show someone how effective it is. If you can show the results of that, sometimes it becomes a little less scary than just the idea of, well, we're going to deploy stuff automatically. But yeah, a great question and kind of a hard one to answer, unfortunately. So let's move on. We'll talk about the way that a lot of organizations implement DevOps. And a lot of the time it's not ideal. So one of the ways that I see really, really regularly is having a DevOps department. So a silo or a part of your organization that does all the DevOps. And I really love this tweet from Timo. Having a dedicated DevOps person who does all the DevOpsing is like having a dedicated collaboration person who does all the collaborating. Obviously, that's kind of a silly thing to do, right? DevOps is not it's not a set of tasks that somebody does. It should be more about the organization and the people in those teams working together with that same end goal of getting value to customers. So I really love that quote. And quite often that is how organizations will implement it. This is the DevOps department. They do all of the DevOps stuff, right? The second way I see it implemented is that DevOps is basically just the new name for operations. And so none of the actual software delivery stuff happens, but the operating of the applications in a production system now happens, and that's the DevOps team. So this is really modern ops, right? This is doing things like using scripts to spin up infrastructure and stuff like that. And it's valuable, it's absolutely valuable, but you're not getting the buy-in from the people writing the code. And you still get those problems where the developers will write some software and then throw it over the wall to now the DevOps team who does all the operations. And without them working together, it doesn't work. The other one, of course, is where the dev team now just becomes the DevOps. And this is quite often called no-ops, right? So you don't have an operations team anymore. You can just spin up an app service in the cloud And so why do you need a DevOps, or why do you need an operations team, right? And this leads to fantastic things like security vulnerabilities and bills that skyrocket because the person implementing that stuff, the infrastructure requirements, is not an operations person. They don't know, they don't have that skill set. And so that often fails as well, or often leads to problems as well. The final way that I see people implementing DevOps is what I would argue is the right way, which is a cross-functional end-to-end team. Right? And I will point out as well that cross-functional doesn't mean that every person in the team knows how to do everything from dev all the way through to the operating and all that kind of stuff. It's just that the team itself consists of people who cover that whole end-to-end life cycle. So this means you're really kind of separating your product into these whole vertical slices where the team is responsible for everything. So you'll often hear DevOps practitioners and people talk about whose responsibility it is to do something. And the answer is always it's the team's responsibility. Often that comes down to a single person, but it should be the team who is responsible for that. If I write code, I should care about how it runs in production and what happens in production with that code. All right. So I'm going to talk about a few different steps in the process of software delivery, and we're going to talk about some of the ideas and some of those tips and recommendations that I've said I'm going to make, and we're going to tie them back to these first principles as well, these ideas that I initially put forward. So these are the steps we're really going to look at, and while you're reading through those, I'm just going to grab a quick drink. So we're going to look at a lot of these different steps and how effective DevOps can guide your decisions and some of those decisions that you might want to make as well. So this is based on my experience through 20-something years of software development and all the other stuff that I've done as well. All right, so let's start with planning. Invest effort when you need it, right? So this is a really common thing from Agile, right? You don't need to spend a lot of upfront effort to work out exactly what software you need to write. We learned this from waterfall software projects where we plan everything in an effort to make sure that it will never go wrong and we'll never miss our deadlines, and we know it just doesn't work. This ties back to that second way of DevOps that Gene Kim talks about, where we have this feedback loop. There's a really big, there's a great quote from an ex-employee of Microsoft, Sam Guckenheimer, who was talking about all of the features that got delivered with the Azure DevOps product itself. And he said that when you deliver a release of Azure DevOps, about a third of those features that you implement, people love them and they want you to keep working on those. About a third of them, people are indifferent. They don't mind whether it's there or not. Maybe they'll use it, maybe they won't. And a third of those features, they hate. They don't want you to continue with them at all. Right? Now, if you're releasing your product every 6 months, that rule of thirds still applies. It just means that you've spent 6 months spending time and investing effort on these things that people don't want, right? If you can shorten that cycle time to a very short period, let's say, or they got to about 3 weeks is when they do major releases, that feedback loop, that second way of thinking about DevOps shortens, and you get more effective feedback on what you're wasting your time on and where you should invest effort. So all of this upfront planning falls into that category as well. You should really only be investing that effort in working out exactly the details of the feature when you think you need it, right? When that comes to the practical side of managing a backlog of tasks, that means that you need to groom your backlog regularly. So grooming is really just going through all of the tasks that you have on your backlog, working out which ones should float to the top, which ones should be removed, and which ones should be deleted. And the deleting is really, really important. I've worked in a lot of teams as well where you have a look through that backlog and you see these items that you have in there that have been there for 6 months, but they've never really floated to the top because they're not that important. I would argue those should be removed. Pick a period of time, and if you haven't got to a feature, remove them. If it is actually important, it'll come back, right? As long as you're talking to your customers and working out what to work on next, that item will come back onto the backlog. But if you have 500 items and you never get to 400 of them, that's just noise, and it makes it really difficult to focus on what you're supposed to be working on and delivering that value. I would also say put in effort so that you learn about the issues in your software first. So this comes down to another concept in DevOps called shifting left. And if you think about this life cycle of an idea all the way through to production, and you think about the idea on the left and the in production to the right, and this pipeline going from left to right, if you are able to identify a problem or an issue as far left as possible, it becomes much, much cheaper to fix, right? So if, for example, you write a bug and you notice it when you compile it on your local machine, that is a really cheap fix. If you don't notice it until it's in production, that can be really expensive to fix. So you want to be the one who learns about those issues first. But the issues can also be whether something is actually valuable or not. So you want to be able to identify what people are doing in your production system. You want monitoring, you want observability, you want all of those things so that you are the one who says, it appears that people are having trouble with this problem, rather than having phone calls saying, this feature that you just wrote is useless, we're not going to use your product anymore. So from a planning perspective, these are my kind of major points. Only invest the effort in features and writing code and planning when you need it. Groom your backlog regularly and get rid of anything that's old, because it's just noise that makes it difficult to plan. And then make sure you invest effort as well in learning about what problems are first, so that you can identify them, put them into the backlog in an appropriate way, and deliver value through to production. All right. By the way, I'm happy to answer questions at any point in this as well. I have the chat open just below, so I'll keep glancing down at that as well. So let's leave planning. Let's move on to writing code. So this is one of the tips that I've learned from writing code for 20 years, is to organize your code by deployable units. So people will ask, do I put all my code in one repository? I have microservices. Do I put them all in one repository and separate them by folder? Do I put them in multiple repositories? If I'm doing infrastructure as code, do I put the infrastructure in the same repository as the code that's being deployed? All of those different things. The one thing I'd point out here is that if you're doing true microservices, that microservice should be a deployable unit. You should be able to deploy that microservice entirely by itself and upgrade it entirely by itself. In that respect, I feel like those should be in their own repositories. Now, this is personal opinion. There's nothing really stopping you from keeping everything in one repo, but I like the idea of keeping these repositories separate and organized by what you actually deploy at the time. Now, if that is your infrastructure alongside your code every time, keep that in the same repository. If the infrastructure is always deployed completely independently from the software, and for various reasons I don't generally recommend that, but that's a whole different discussion, then your infrastructure could live in a different repository from the applications itself. So think about organizing your code by the way you actually deploy that code. It makes things a lot easier. We talk about CI, continuous integration, and it's important that continuous integration is not continuous isolation. So a lot of organizations have branching strategies for their code bases, where they will have a main trunk of their code, and then when they work on some code, they will create a branch, work on that code, and then merge it back in when it's complete. Even back in the old days where we didn't have distributed version control, like Git and Mercurial and things like that, or we didn't use it very much, people would still tend to check out files, work on them for a period of time, and then check them back in. Right? The problem is, if you keep that code checked out, or you keep branch separate from that main branch for a long period of time, you have this isolation from the main branch. And the more developers you have and the more teams you have, and the longer you leave those branches not merged back into your main branch, the more isolated that code becomes and the harder it is to merge later on. So to explain a little bit more, what I'm talking about is short-lived feature branches. So in other words, write a feature branch or create a feature branch for some work you're going to do, and then make sure you merge that feature branch back into your main branch on a regular basis, or at least soon, right? If you've kept that feature branch away from your main branch for months, then it can be really hard to merge it later on. You're really practicing your continuous isolation. You're isolating your code from the rest of the code. And CI is about continuous integration, integrating your changes with everybody else's changes to make sure they still work. Short-lived feature branches. Now you might be thinking as well that can be really hard when it comes to big changes, like really large changes that cause all sorts of that might take a period of time to implement. And I would recommend for long-running tasks over long-running code changes, this technique, and this is a little controversial. The idea of writing dead code. So writing code that does not get run, but still gets deployed to production. So this is the concept of, let's say you have a mapping function in your application and you want to change from Google Maps to Bing Maps as an example. And this is going to take a long, long time to implement. Your first step would be to do a feature branch and then refactor that code so that you're abstracting away the implementation details of what's actually going to provide that mapping function. Just create instant interfaces, use dependency injection, inversion of control, all of those kind of techniques. And then just commit that code and push that back into that main branch. So the first step is refactor it so it's easy to replace that code with new code. And then just commit the same stuff back in. So the function doesn't change. The actual features don't change. You're using the same functionality, but now you have a situation where you can do another feature branch and write a new implementation of this mapping code that can even be deployed to production, because when it gets run, it will still point to the old code. Now, it's a little complicated to explain without seeing code and diagrams and stuff like that. More than happy to follow up with people later on if you would like some more information on that. But this allows you to write these really short-lived feature branches and do continuous merges and then only swap to point to the new code when you're confident that it works. So there's a lot in that. And I have seen there's a question as well, and I'll come back to that in a second. It's a little bit detailed in terms of the implementation, so I'll come back to that in a little bit. I have seen it. Thanks. We can also, when you're writing code and when you're doing continuous integration, we can also shift left with pull request builds. So we talked about shifting left, discovering problems as early as possible, using a pull request process where you branch away from your main branch and then submit a pull request back into your main branch from your feature branch. You can run builds or continuous integration on that pull request itself. You can run a build to make sure that everything compiles, your test will run, everything looks fine, and only if that succeeds, then merge that back into your main branch. What that means is you're discovering these easy problems further left in that life cycle, and your main branch remains protected. So this is a really, really good practice to get into. Azure Pipelines Azure Pipelines and Azure Repos implements that really well. GitHub implements this really well as well with checks, pull request checks. So really, really easy to do this stuff with the current tooling. I would highly recommend it. It definitely improves the quality of your code. So this is kind of the summary of the writing code section. And again, feel free to ask any questions. I will come back to that one a little bit later, just because it's specific to some products. My recommendations: organize by deployable unit, so repositories based on what you actually deploy. Practice continuous integration and not continuous isolation. That's really important. Use short-lived feature branches, which might mean writing some dead code, refactoring so that you can continually merge back into your main branch without breaking stuff. And then have a look at PR builds, pull request builds. That can be really, really handy for this idea of shifting left. Now, all of these things, I haven't really spoken specifically about the principles that I mentioned at the start. All of these are really based around this feedback loop. So integration, continuous integration gives you this really short feedback loop. Shifting left with the pull request builds gives you that really short feedback loop. Having feature branches that are short-lived lets you know when your code has drifted from the main branch so you can fix problems early rather than having to fix them later. And then even organizing by deployable unit, that can tie back into this simplicity and what was that one? Simplicity and locality, or locality and simplicity, meaning that you can work purely on this piece of on this repository, on this piece of code, which helps you work efficiently and effectively. So all of these things are really based around those first principles as well. All right, let's talk about the infrastructure. Having infrastructure as code, which you may have heard of, is really about avoiding avoidable problems. So you're not deploying to an environment for the very first time when you go to production. So if you are defining your infrastructure in code, and when you deploy, you're deploying that infrastructure and the application on it, you're putting in place the exact system that you're going to put in place for production. If you have that infrastructure defined in code, it means you know what production looks like. It's right there in code. You can wipe production away and do it again, and it's exactly the same thing. It means that you can spin up test environments really, really quickly because you know what production looks like. So you know what that test environment has to look like. You're avoiding these problems of, oh, well, it worked fine in our dev or QA environment. The idea of knowing what production looks like is really, really important for when you need to patch or rebuild your environment as well. You can verify this before you apply those changes to production as well. So it's exactly the same as your code. Like, you wouldn't make changes to your code in production. You make changes to your code in your local machine, and then you test them and make sure they work. And then in a CI pipeline and make sure it works there. And then in a test server and make sure it works there. You can do the exact same thing with your infrastructure, and that means you can be more confident that by the time it hits production, it's actually going to do what you want it to do. These reproducible environments you get from defining the infrastructure in code mean that you can spin up a test environment for this pull request that you're putting forward, or you can actually spin up a test environment to test a little idea that you have and then tear it down at the end. Because the environment's reproducible, you get this this idea of locality and simplicity, where you can just do your work and deliver value and be able to see that that value is there before going through the process of committing that and pushing that all the way through to production as well. Ultimately, the idea here is that the infrastructure that your software runs on is part of that software. Right? Your software does not exist in isolation. It absolutely affects the way that your code runs as well. So your code could be the best code in the world, but if the infrastructure won't support it, it's not going to work and it doesn't deliver value. Once again, we're back to delivering value to your customers as well. So there was another question as well about infrastructure as code, best practices to secure credentials in DevOps. I imagine Azure DevOps. So Azure Key Vault, if you're in the Azure ecosystem, is really, really handy. It can integrate really cleanly with variables in Azure pipelines. And there's also there's actions for GitHub Actions as well. So as part of your workflow, you can pull keys and things from Key Vault. Now, Key Vault is the secrets management and certificate management and all that kind of stuff that's in Azure. There are other tools in other products as well, and from other vendors as well. And I will come back to that question now just because I'm answering some of these questions. The question was about how DevOps can bring in end-to-end real value in projects with internet restrictions. So there's a couple of ways that this can work. One is by using government cloud. So if you do need cloud stuff, there are Azure regions that are specific to government. Now that might not apply in your area. If it doesn't, that's not going to be a solution. All of these products as well, Azure DevOps, for example, has Azure DevOps Service, which is the one we usually talk about, and that's the hosted version. But there's also Azure DevOps Server, which is the one you install on your local machine. Now, it does everything that Azure DevOps Service does, but you can control where that gets installed and can completely control your internal environment. So it doesn't have to reach out at all. All your code can be internal, all of your pipelines can be internal, and all of that kind of stuff. GitHub Enterprise as well, if you wanted to use GitHub and GitHub Actions and things like that, GitHub Enterprise Server is one that you can install locally as well. And it was earlier today at GitHub Universe that they announced GitHub Enterprise Server 3 or 3.0, which adds GitHub Actions and a whole bunch of other stuff as well that was missing from that on-premises location. So if you wanted to use GitHub as well, you can do that all in your local environment too. And that's end-to-end all of the tooling that you have with DevOps as well. So hopefully that helps answer that question. All right, so let's just summarize the infrastructure part. This is really about avoiding avoidable problems by identifying the fact that your infrastructure is part of what your software does. Right? It's not completely independent from the code that you write. Having this defined in code means that you can reproduce those environments whenever you want. You can make changes to those environments and verify that they are actually going to work with your software exactly the same as you do with your other software as well. And all of this leads to better value and a faster feedback loop if there are problems with your customers. If something goes wrong, it means that you can fix it in a much faster way as well, rather than trying to remember what somebody clicked on in the production environment. All right. Let's talk about testing, right? I strongly believe that bugs are just a form of technical debt, right? If you have a bug in your system, that is something you have to fix later on, whether you know about it or not. So if you don't fix that immediately, whether it's because you are unaware of it or you think something else is more important, that is technical debt that you have to pay off later. So you need to manage your bugs and keep them at a low level in order to maintain the quality of your code. Now, what this often means is companies will say, well, that means we need 100% code coverage of all of our tests, right? Which can be a difficult thing to do, especially if you have an existing application that you've been working on for a period of time, right? In which case I would say better is better than perfect, right? You don't have to have 100% code coverage. And in fact, I really hate that metric because it doesn't actually test what you think it tests, right? It means that all of the code gets exercised when you're running your test. It doesn't mean that you verify that there are no errors. I mean, you could write a test case that just doesn't have any assertions at the end of it, and you'll still get 100% code coverage because you ran through all that code, but you didn't test whether it did what it was supposed to do. Rather than trying to implement tests across your entire code base, every time you touch something, write a test around that change. One way of doing this, especially with bugs, is this idea of red-green refactor, which I love, which is the idea of rather than going in and fixing a bug that you see, write a test that will go red, that will fail, right? To identify that there is a bug there. Then you fix the bug and verify that the test goes green, it succeeds. That means that in the future, you can do any refactoring you want. You can touch that code however you want, and you know that you have a test around it now, right? So you've improved the state of your code base. And it has meant that you didn't have to go through the whole code base writing, tests in a boring way. You've actually got tests around stuff that you know has caused problems before, and you know it won't be a problem in the future. Another one is that all of your tests should pass every single time. This is a tricky one for some people. Often there are tests that are a little bit flaky. The problem is that flaky tests give you a false feedback loop. So if we look at that second way that Gene Kim talks about with the effective and amplifying those feedback loops, if a test fails sometimes, that means you don't care about it, right? You'll see it fail and you'll say, oh yeah, that fails sometimes, right? So all of your tests must pass, otherwise it's just noise which is hiding the feedback you actually want. So all of your tests pass every single time. The Azure DevOps product, by the way, has about 86,000 unit tests, and every one of them runs every single time there's a change to the code, and every one of them has to pass, otherwise you can't merge back into the main branch. So we practice what we preach here, right? Everything passes every time. So, little summary of that. Bugs are technical debt, and you have to pay down that technical debt, otherwise you end up with interest, and you end up in a situation where you can no longer get that focus, flow, and joy because you always have these problems that you have to work around in your code because of this technical debt. Better is better than perfect when it comes to writing tests. Just try to leave things better than they were when you touched them. That's really about your improvement of daily work as well. So again, Gene Kim's 5 ideals. Improvement of daily work is really important, making sure that the code base is nicer for the next person and you in the future, of course. One way of doing that, red, green, refactor, and then make sure all of your tests pass every single time. All right, we got 3 more. We can get through this. Building and versioning your software. I love the idea that I really established in my head in Octopus Deploy, at Octopus Deploy, which is that you build your software once and you deploy that same artifact many times. You deploy that artifact to your test site, to your staging site, to your production site. Don't ever rebuild to deploy to an environment. And I see a lot of branching strategies where the dev branch is the thing that goes to the dev environment, and then you merge into the test branch and that goes to the test environment. The problem there is that when you are testing the thing that you deploy to your test environment and all of those tests pass, then you recompile everything or you rebuild everything and deploy that to production. You're deploying a brand new artifact. You're deploying a thing that you haven't tested. And sure, 99.9% of the time it's going to be the same, but there are cases that I've seen in the real world where what's been deployed to production, even though it was the same code, doesn't work the same way because there was an operating system update or updated the framework version on the build server or something like that. So build it once, deploy it many, many times. Only server builds matter. Your local build doesn't mean anything. If you can compile it on your local machine, it doesn't really matter at all. It's only the thing that happened, only the artifact you build that's going to get deployed to production in much the same way as before. The reason is not just that that's the one that's going to go to production. It's just it's also that your dev environment does not match what production expects. Right? You might have dependencies and extra things built in your machine that the build server doesn't have, so it's not going to work then. Or somebody else might have changed the code in a way that you didn't expect. So it works fine on your machine, but when you merge your code with everybody else's, it doesn't work. So only server builds matter. When it comes to versioning, I strongly believe that every build should be uniquely identifiable. You shouldn't be building version 1.0.1 and then make some changes and end up with 1.0.1 again. And the reason is that provenance is key. It's really important to be able to look at an artifact that you've got, a version of your software, and say, this software is the culmination of all of these changes in my code base, right? If I look at a version of my code, a version of my software, and say, this is version 1.0.1, but I don't know what code is in that, then it makes it really, really hard to complete that feedback loop, that second way of DevOps, thinking about how do I identify the problems in the code that's running in production. So again, build once, deploy many times. Only the stuff that builds on the server really matters. Every build should be identifiable, regardless of what your versioning strategy is, because provenance is key. And I'm moving a little bit faster now just because I realized the time, and I apologize for that. Deploying to production. I love this quote that I heard from someone. I don't know where it came from. I think I've heard it a few times. That production is a test environment. And the question, could I share the slides afterwards? Absolutely. I believe this is all recorded too, but yep, I can send the slides through as well if you'd like them. Production is a test environment because you never really get a true test of your application until it's running in production with real users, right? Anything in pre-production is a simulation of what production looks like. So this idea of test in production works in two ways. It means that you can actively test what the stuff that you want to do by turning on a feature flag and see if it actually works for people, and turning it off. You're testing that in production. But also it's this idea of understanding that what happens in production is happening there for the first time when you do a deployment, right? So if you treat production like a test environment, that means you have to become friends with failure. It means you have to accept the idea that the thing you deploy into production might not work, even if it worked in every other environment and looks absolutely perfect, right? You have to be comfortable with this. Otherwise, you spend all of your time trying to prevent failure and none of your time being able to mitigate it when it happens. And it does happen. Doesn't matter how much planning you do, things will go wrong, right? So make friends with failure and be comfortable with that third way of DevOps, this idea of experimentation and learning. So when failure happens, you know why, you can fix it quickly, and you know you won't do it again. This idea of a faster cadence in DevOps, so deploying less means you risk less. So if you deploy smaller pieces more frequently, each deployment has less risk in it than if you deployed a lot of changes in one go. So to be useful and maintain velocity, to actually get features out, it means that you have to deploy more frequently, and you can't do that without automation. So that's CI/CD and all of the good stuff that tooling does. The other idea which I really like is the idea of bringing production to the developers. So this is the concept that if you start a project and the developers are writing this code and they're getting it all to work and they're using it on their test machines, but then production is this thing over there in the distance that they don't have to worry about until the project deadline, that makes it really hard to write code in a way where you care about what it's going to look like in production. So if you can make production a thing that developers care about and have access to, whether it's the actual production or not, or just the specification of production, that can be really handy for this mindset of ownership, the idea of being able to make sure that the code I write, that I care what it is in production. I also like the idea of separating the deployment from the release. So you can deploy your code into production, but you don't need to release that feature until everybody's ready, or until people are ready, or until you think that feature is ready to go. So again, GitHub Universe happened today. All of those features that they announced at GitHub Universe that they just turned on during that keynote, they'd all been deployed weeks ago, right? That deployment, it was a purely technical act, right? They deployed the application, but they didn't release those features until everyone was ready, right? So being able to deploy that, deploy code and then turn it on a flag and release that to the public means that you can also roll it back if you want by turning that flag back off. You remember where I talked about writing dead code, so code that lives in production that's not getting called? By implementing things like feature flags, it means that you can now flick that over so it does call all that dead code. So this is how it's done in practice. All of those features that were announced at GitHub Universe today, they'd all been deployed, and then a feature flag just turned them on. It also meant that we could test them before they hit the mainstream. So I got access to some of the GitHub Actions stuff before it was released because they could just turn that flag on for me. That dead code became live code just for me because of feature flags. Really, really handy way of doing it. And shortening that feedback loop and making sure you're amplifying that feedback loop of, this is what's happening in production. Really handy. So Production's a test environment, and anything else is a simulation. That means that things will go wrong. You need to acknowledge that and accept it. Otherwise, you're never going to be able to recover from failure because you've spent too long trying to prevent it. If you deploy less, there's less risk. You can separate the deployment from release, and you can do that with feature flags as well. And I realize I'm running out of time. I apologize. We'll keep going. There's just one more with gathering feedback, and then I'll hit some questions as well, just if people need to leave. I'm not keeping them for too long. So gathering feedback, again, customer focus is key. And this has come up in a few different things. This is part of the 5 ideals, and it's obviously part of Microsoft's definition of DevOps as well, focusing on value to the customer. I really love this this T-shirt. It came from, and I've just had a mind blank on her name, Mipsy Tipsy on Twitter as well. 9s don't matter if users aren't happy. So if you have a 5-9 system, if the users don't like your system, it doesn't matter. Really, really cool idea. That means hypothesis-driven development. You think this thing you're putting into production is going to deliver what people want, but maybe it won't. So that's just a hypothesis, and working on that principle means that you can focus on that feedback loop and whether you're actually delivering value. Again, the definition of done that people use a lot. If you treat whether done means something's valuable or it's not, but you learn something, that can be far more valuable from a DevOps perspective than thinking done means I've written the code or the code works. Done should be it actually is valuable to somebody, or we've worked out that it's not valuable, but we learned something and we're going to focus on a different area. And of course, that means if you don't measure what people are using or whether people are happy, then you can't know whether they're happy. So that has to be a really important part of this whole process. All right, customer focus comes up a lot in those principles. Realizing that what you're delivering to production is a hypothesis about whether people will use it or not. The fact that done should mean that something is valuable rather than I just wrote some code, which means you need to be able to measure whether something is valuable or not. Otherwise, you can't know and you can't focus on value. Right, so that's those ones. I just want to revisit these really quickly. Microsoft's DevOps definition, really easy to find that. If you search for those words, it'll come up 1,000 different times. The 3 ways from Gene Kim, that's really, really important. Those ones, I like to think about DevOps in these ways a lot. These 5 ideals, and of course the 2 books that Gene Kim's ideas came from. I would also recommend the DevOps Handbook and the Accelerate book as well. Those are really, really good books as well. And again, I'll share the slides so you can see these later. The State of DevOps report from Nicole Forsgren and others is fantastic. Continuous Delivery is a fantastic book. A bunch of books from from people in my team. All of these as well, you can find them in a gigantic gist of resources there from DevOps resources. And the DevOps Lab that Asif mentioned at the start of the session as well, that video show, feel free to check that out. You can get hold of me on Twitter at DamoVisa, and I'm going to leave that slide up because that has the important links. Again, apologies for going over for a few minutes. I hope it was valuable, and feel free to hit me up with any questions. I'll pass over to Asif. I know there's a question in there. I will answer it in text, but if we've got time for questions, just let me know.
Hi guys, if you have any questions, you can unmute yourself, you can ask directly. Hi Damian, I have one question. Could you suggest any book for the DevOps versioning strategy? Because I feel that in my organizations, people are very confused about the versioning of the code. So yeah, if you have anything.
Sorry, can you just say the main part of that again? I think my headset just cut out.
Actually, it's for the DevOps versioning, the code. So basically, in my organizations, it's completely a lot of messed up code, and the versioning, they're not doing the version correctly. So if you can suggest any resources for that, so that will be
Yeah,
helpful.
so version numbers and
Yeah.
things like that, you mean? Yeah, so I really like Semver, which you may have heard of, which is semantic versioning. Um, it can be tricky to get that working really specifically, but there are a lot of tools around for it. So I'll just type that in. So if you look that up, there's a lot of integrations for Azure DevOps and for Octopus Deploy and for TeamCity and for GitHub Actions and things like that that will implement that Semver idea. But basically, it means you have a major, minor, and patch version number. So you know exactly if a number has changed, exactly what types of changes have been introduced. My general belief, though, is that as long as every single build has a version number and that version number increases, then that's 99% of the job done. So a lot of people just do year, month, day, and then a counter, and that works. It means you can look at a version and say this version is newer than that version. The other important thing is that all of the code that you deploy should come off that one branch. So if you have a version of your software that came off a main branch with a version number and a version that came off a release branch with a different version number, you can't look at those two versions and say this one is newer than this one because they came from different sets of code. So yeah, that trunk-based development is what it's called, where your main branch or your trunk is the only code that you're ever deploying, and that means you can have this consistent versioning strategy. So yeah, Semver is a good place to start, but I don't think it's that important to be as strict as Semver. But there are some good tools around that as well. I also saw another question. Sorry, I haven't answered about DevOps for bespoke development. It's great. Any best practices or guidelines for DevOps for product-based implementations like SharePoint, Nintex? I don't know Nintex very well. I do know that SharePoint, it's possible now with modern SharePoint to automatically deploy that stuff and to build those changes into pipelines. I'm not a SharePoint developer, so I don't really know the details. One technique that I've seen with SharePoint, I don't know whether it's applicable now, is to build applications that aren't part of that main SharePoint implementation. They're kind of applications that live inside SharePoint. And so building them and then deploying them kind of separately means that you're not really hamstrung by the way that SharePoint works as much. But the general idea of these products where you have to make changes in your test environment and then make those same changes in your production environment, that can be quite tricky. Often it's a case of using an API if they have one, or if you can serialize the definition of what it looks like into JSON or YAML or whatever it is, and then deserialize it into production as well. But yeah, it's a tricky thing with some of those tools. I'm afraid I don't have a better answer, unfortunately, for that one. Cool. Yeah. Great. Advice to decide on DevOps tools. The two that I always recommend, especially for CI/CD, GitHub Actions and Azure Pipelines. But the decision between those two is a tricky one. If your code is in GitHub, then I would strongly recommend looking at GitHub Actions as your first choice. If your code is not in GitHub, then you can't use GitHub Actions anyway. So Azure Pipelines is a good solution there. If your code is in GitHub and GitHub Actions doesn't do what you need it to do yet, and that gap of what it does and what people need is closing every day, then Azure Pipelines is a good place to start. If you're worried as well about Azure Pipelines being discontinued and everything going to GitHub Actions, it seems as well like that's the direction that things are heading, but there's so much investment in Azure Pipelines, especially internally at Microsoft, that there is no way we can get rid of that product without having a really good migration path to GitHub Actions. We just have way too much investment internally, and we know a lot of people have so much investment in Azure pipelines as well. There's no plans at the moment to deprecate Azure pipelines, and even if there was in the distant future, we'd need to make sure that there's a good migration path. So you can feel really safe using Azure pipelines. There's still a couple of hundred developers working specifically on Azure DevOps, so it's not an abandoned product by any stretch.
Yeah. Thanks, Damian. It was a really nice session and very interesting tips. Hi guys, if you have any questions, so you can unmute or you can ask, or maybe you can later on you can send an email, either one of us, or you can send a Twitter to Damian. So
Yeah,
ask if anything. And
yep,
he
so
has
that
a nice channel, so you
yeah.
can just go and take a look of that. So yeah.
Awesome. Yeah, thank you, everyone. That Damo Visa as well is me on Twitter, but you can also email damovisa@microsoft.com, and that would get to me too. So if you prefer email.
Yeah.
Yeah. Cool.
Okay.
Yeah.
Yeah, go ahead.
Feel free to reach out. Yeah. Excellent.
Okay, thanks again, Damian. Hope we see you again next time physically, or maybe another session on the DevOps. It's a really nice session, and we love it.
Yeah. Awesome. Yeah, thank you very much for inviting me.
Thank you.
That's been great.
This session is recorded, so we will post this recording on our YouTube channel, MVP YouTube channel. Yeah, so if you guys need anything, you can take a look.
Great. All right. Thank you, everyone.
Thank you, Fadal.
Right.
Okay. Yeah. So.